Okay, convert. Yep, because positive 2 would have gone along the line right here, but since it's negative 2, we go backwards.
Gotcha. Okay.
Okay, polar coordinates. To convert to rectangular coordinates, this is where we use the x is r cosine theta and y is r sine theta. If we needed to have this memorized, I use the, these are in alphabetical order sort of trick that x and cosine go together and y and sine go together, like, because x is before y in the alphabet and c is before s. But all we need to really do is we could put these in the calculator. Or we could draw a picture and make special right triangles, whichever one you'd like to do. But if we're using our calculator, we need to make sure we're in Radian mode. So remember, it says it up at the top of your calculator. If you have a TI 84 plus, so that it's really easy to see which mode you're in. You know you need to be in radian because these angles are in radians. So I'm going to do 4 cosine 5 pi divided by 4, and I got negative 2.83. If I rounded 2 decimal places. And then I'm going to do the same thing but with a sign instead. Oh, interesting. That's also negative 2.83. If we'd drawn a special right triangle, we probably would have noticed that those were going to be the same, because 5 pi over 4 is some version of a 45, 45, 90. If we did a, if we did a special right triangle, I think we'd get square root of 2 over 2. No. Something times square root of 2 over 2. Because square root of 2 over 2 is not negative 2.83. Oh well. 4? Maybe. Yeah. Good job. So, for 10, 2 comma pi over 2, again, we can just do 2 cosine pi over 2, 2 sine pi over 2. And I don't know if it makes you nervous that like the first one gives you 0, but that's because pi over 2 is up here. And so, yeah, the x coordinate is going to be 0. And then 2 sine pi over 2 should give us 2. So these on 11 and 12, where we're going the opposite way, require a little bit more effort because we're basically thinking about a triangle. So square root of 2 over square root of 2 over 2, comma, square root of 2 over 2 is a point in the first quadrant. I would hope that you might realize pretty quickly here that this is a 45, 45, 90 triangle. But if you don't, I guess that's okay. The way we come up with the radius is Pythagorean Theorem. So you'd square both of these and then square root after you add them. You square them both, which gives us, each of these would be 1/2, and you add them together and get 1, and then you square root it, so that this gives you 1. That's the radius. And then the angle here, if you don't know what it is because of it being a special right triangle, that's where we do inverse tangent of those numbers over each other. So whatever y over x is. And so if you're in radian mode, your calculator is going to tell you it as a decimal. If we were in degree mode, it would tell us, hey, this is 45, which then we could say is pi over 4. I guess that I'm actually fine with you putting it in degrees or radians. So our possible answers here are 1 comma pi over 4. You could put 1 comma 45 or you could put 1 comma whatever pi over 4 is as a decimal, which is 0.79. So you don't have to have all of those answers, but whichever one of those answers you were able to come up with would be fine with me. I'm just realizing that 11, 12, 13, and 14 probably could have used a little more room, so whoopsie. So 12, I'm going to draw the picture mostly just so I know what quadrant this is going to be in. It's a positive 2 squared root of 3 and a negative for y, so that's going to be in this quadrant down here. And so if I do the Pythagorean theorem, I can find the radius that I need. When you're doing this, you put 2 squared root of 3 in parentheses so that your calculator will actually square all of that and not just part of it, which is what we want. If you're putting in the negative, that also should be inside the parentheses on the second one. This gives us 16, which we square root. I don't know why I did that on my calculator, because I know that's 4, but it is 4 for our radius. For the angle, we do inverse tangent of negative 2 over 2 squared root of 3. And this is actually going to give us a negative angle. The instructions say to have an angle between 0 and 2 pi. I'm fine if you want to put the negative angle, that's fine with me. Because this would be, if you use your calculator, you get negative 1.05. I'm okay with that. But our other options are that we could get, what is this angle actually? A negative, so it's positive 330. Oh, yes. It's negative 30. So like, look at all these options we have for how we could write our answer. And this is the same as pi over 6. So you could have negative pi over 6 or 11 pi over 6. And this is why the instructions have that added bit of between 0 and 2 pi, because they're trying to make it so you only get one answer instead of there being a bunch of different answers. But I'm not planning to be picky, is all I'm trying to say here. You guys remember how to do 13 and 14. We don't need to do those, right? Just kidding. Okay. So the vectors, this is where we had to find x and y components for each of these, so that we could add them together, and then we changed them back into polar coordinates. And so basically there's nowhere near enough room for this in this little section. So apologies there. Gonna come, can go over here. There's not enough room. I'm so sorry. I was not thinking about room. So I'm gonna come over here to the side. You have the back of the other page if you wanted to use that, I guess. Would be the probably easiest place to put it. See, problem solving. So we're gonna use r cosine theta and r sine theta to find our x and y components for each of these. So these are in degrees though, so we do need to switch our calculator to degree, which means go to mode. It's the 4th option. You should be in radian because we just did something in radians, so make sure you change it to degrees. We're gonna round, it doesn't say what to round to, so we'll just, round to 2 decimal places, I guess. This would be 14.63. Sorry, I did r cosine theta, comma r sine theta. So I typed 20 cosine 43 and got 14.63. And now I'm going to do 20 sine 43 and get 13.64. And then I'm going to do the same thing, but with the second vector instead of the first vector.
It's the same movie that's rearranged.
Interesting. Coincidence? I think so, actually.
Yeah.
Both of these also were rounded up, so that would have made a difference. If you didn't round them, obviously they wouldn't have the same digits rearranged. Okay, 6 cosine 29 is 5.25, and then 6 sine 29 is 2.91. So we're going to add these together to get our resultant vector. And just kind of as a reminder of what this is actually doing is we're thinking of a first vector that maybe looks kind of like this, has a magnitude of 20, and then we're talking about a second vector maybe looking like this. Well, that's too long. Let me try that again. It's only 6. Ugh. And so the resultant vector connects these, and so this is what we're actually trying to find. So if we add these together, it'll give us the x and y components. 19.88. 16.55, and then it wants the magnitude and direction, so that's changing them back to polar coordinates. So Pythagorean theorem and inverse tangent will do that for us. So this gave me 25.87 for the magnitude. And so for inverse tangent, we always do y over x because the way things are positioned, the side that gives us, the opposite side goes with the y value, and the adjacent side ends up going with the x value. So if you're thinking of SOHCAHTOA, the TOA, T-O-A, tangent, opposite, adjacent. That gives me 39.78. And depending on how good a job I did of drawing this, this should actually kind of look like it could be 25, 40, which, you know, it kind of does, I guess. It's not terrible. Yeah, everything's better when you're doing it the second time. So, so those of you who have not taken physics, if you do take it when you get here, you might be like, oh, nostalgia. Remember the good old days of precalculus?
These aren't very hard. They just take a long time and tolerate.
Yeah. I agree.
I think that's mostly just because Pythagorean theorem takes forever, but it makes it pretty simple.
Yeah. It's we're having to convert it to x's and y's and then convert it back, and that's kind of frustrating. It's like, why isn't there a way to just somehow add these together and get polar coordinates? But there's apparently not. Otherwise, that's what I would have taught you how to do, right? Like, okay, so our cosine theta, our sine theta, we are going to get, this is going to be in kind of a different location, I think, because of our angles. Like 289 is fourth quadrant, 121 is in second quadrant. This could be interesting, what we end up with. I don't know that I'm confident that I could draw this in a way that would be anywhere close to correct. So 6.51, comma, so I used software to create this, and I thought it was interesting that 289 and 121 are both perfect squares. Yeah, I don't know what sort of logic there might or might not be in the generation of these problems, but I thought that was interesting. This one, negative 7.21. And 12.000.
Is that top one negative 18.91?
It is. If you do decide to draw them to try to like kind of check your end answer to make sure it makes sense, it might actually be easier to draw it from the x and y coordinates than from the 289 and 121 degrees. Like that seems like, for degrees, that seems like really random places to have something. So like if I'm trying to draw this, I might be better off going, okay, over 6 and down 18 would be something like this, but then I'm going to go left 7 and up 12. So I'm going to go left a little bit more than what I went right. I'm going to go up 12, not as much as what I went down. So see, this goes kind of backwards. It looks like we're going to end up in the third quadrant here. So 6.51, whoa, plus a negative 7.21, also known as minus, and negative 18.91 plus 12 is negative 6.91. And then Pythagorean Theorem and inverse tangent. Now, inverse tangent's gonna not give us the right answer because inverse tangent's not as smart as it should be. But I guess we can forgive it. It is what it is. So, using the Pythagorean Theorem, I got 6.95. For the radius. When I do inverse tangent, the reason it messes up and doesn't give us the right answer is because it thinks that the inverse tangent of a negative over a negative is the exact same as the inverse tangent of a positive over a positive. And those are not the same thing because those are talking about angles in completely different quadrants. So if I inverse tangent and I type these in, it's going to give me the reference angle, which is 84. So it's telling me this angle right here is 84. It's telling you the closest angle to the x-axis, 84.22. So we're going to add 180 to that, which is going to give us the actual angle we want. So
it will always be 180, or
it's 180 plus if it's in the third quadrant, or 180 minus if it gives you if it's something in the second quadrant. So if your angle is in the first or third, first or fourth, it gives you the right answer. It'll either give you a positive angle or a negative angle. But if your answer is supposed to be in the second or third, it'll give you the answer as though it was in the first or fourth quadrant. And so you have to add or subtract from 180. So this ends up being 264.22. Repeat. So, go figure. Oh no, I erased part of 16.
x minus nothing.
Yeah, x minus, pick whatever you want. Okay, so 15 through 19 may look kind of difficult, but this is where we were just adding or subtracting, multiplying, dividing, that sort of thing. So I don't think it should be as bad as you might originally have thought of it would be. Like if I want to do h of a plus g of a, it's just saying take a minus 3 and a cubed minus 5, add those together, which means look for like terms If there aren't any like terms, we would literally just put them next to each other. There are some like terms here. The -3 and the -5 can add together, but the a cubed and the a cannot. So our answer would be a cubed plus a minus 8. Easy peasy.
I'll pick the wrong one.
Subtracting is a little bit trickier because when we subtract, we're not adding. So, you know how it goes. Isn't it? So when I subtract 2x, I really add 2x. And when I subtract 5, I really add 5. And so that would give us 3x plus 3. It's an easy thing to overlook. Either to just not do it at all or to change the negative 2x but not change the -5. So, there you go.
What was the...
Yep.
Just making sure I'm correct.
Okay, 17, we've got some multiplication here, which is going to require us either to think about FOIL or the distributive property.
FOIL, please.
Okay. Three x plus 3, yeah. So if we're FOILing, we do first, which is 3a times 2a, which is 6a squared. And then we do O for outer, so 3a times -3, which is -9a. I is for inner, so 4 times 2a, which is 8a. Last is 4 times -3, which is -12. And then the middle terms often end up being like terms. -9a plus 8a add together to get -1a. So this would be 6a squared minus a minus 12.
Nice.
Yeah.
This can be confusing to think about, but then the math, once you figure it out, is
Yeah. Fair enough, fair enough. 18, we're dividing, which means we're just going to stick them on top of each other. Don't try to do anything else to it. If these simplify, everything would have, like, there are 4 terms here, 2 on top, 2 on bottom. In order for this to simplify, everything would have to have something in common. So they would all have to be divisible by 2 or all divisible by x, and that's not happening here. My 4 kind of looks like a 9, but it's a 4. Let me try again. Yeah. So that's our answer. The thing that's most supposed to make the division ones difficult is it changes like what you're allowed to plug in for x, because now you've got a fraction, but we're not going to worry about that right now. It's a problem for future math classes. Okay, this was the thing that was actually felt, I think, the most new in this section, that if I find g of f of x, I'm taking what f of x is, and I'm putting it inside of g. So I'm going to stick it where this x is. The way I know the order to do this is you look at the inside, which is f of x, you're putting it into g. So that's -2, and then where x is, I'm going to put x squared plus 5x, and then I finish with the plus 1. I'm going to distribute, and there won't be like terms. If there were, I'd add like terms. This is just -2x squared minus 10x plus 1. I don't think you understand how mechanical pencils work.
I don't know either.
Okay, the best thing since sliced bread, the vertical line test, to determine if the relation is a function. So what you do is you imagine or actually draw a vertical line. If it goes through more than once, it fails, which means it's not a function. it has to be able to pass everywhere for it to pass the test. So this passes the test and is a function because no matter where you draw a vertical line, it will only ever go through once. As opposed to on 21, where you can probably pretty easily see that if we draw a vertical line most places, it fails and goes through twice. So it is not a function.
What if you draw a vertical line and it hits nowhere?
Then it has to pass everywhere. So if you choose to put your vertical line over here, that's great, but no matter where you put the vertical line, it has to only go through once.
Also have to have one everywhere?
No. No, they do not. That's a good question. So we could have a function that just starts at 0 and goes like to the right or something like that. Yeah. Okay. This is not going to take very long, but I do want to finish up these last 4. So this is rearranging these into log to exponential and then exponential into log. You start with the base, which is 17. You go around to the other side to get your exponent. And then you come back around and get your answer of 289. And that's your answer. And it should, if they have numbers, it should actually be something as true. 17 squared really is 289. So this is going to be y to the x equals 129. A little harder to feel confident about since there's so many letters. But if we do it the exact same way we did 22, then that's a good sign. For 24 and 25, we write log, and then our base is the base of this exponential expression. So log base 6, go around to the other side and write down 216, and come back and pick up your exponent. If you went to the effort of typing this into your calculator using math and log base, it should actually equal 3. Log base 6 of 216. So again, you could technically check yourself there. This would be,
pretty helpful to check your answers.
you know, on tests, it is a good idea to check your answers.
Unless you second guess yourself.
Since these ones are so easy to check your answers, that makes
Yeah.
it as well.
Yeah.